For page 46, please label it multiplicity in zeros. So the multiplicity of a zero is the exponent on its factor. For example, if we had f of x equals 2 parentheses x plus 1 squared times x minus 3 to the fifth times x minus 4, this is going to be a polynomial in its factored form or intercept form. And so if I wanted to see the multiplicity, I would take each of the factors and I would find first the zeros. So for x plus 1, the 0 is negative 1. For x minus 3, the 0 is 3. And for x minus 4, the 0 is 4. Now, 2 itself doesn't have a variable attached to it, so it doesn't have a 0 because 2 itself cannot be set equal to 0. And so if I look at the exponents on each of these factors, so 2 is going to be the multiplicity of negative 1. 5 is going to be the multiplicity of 3, and 1 will be the multiplicity of 4. The reason we want to look at these multiplicities is that it is going to determine how the graph will cross the x-axis. For example, if I had x plus 3 to the 1 power as a factor, I know that my root is going to be negative 3. Because this multiplicity is 1, it is odd, but because it's 1, it's going to pass through like a straight line would, like a linear line. So this is what the graph would look like at x equals negative 3. If I had the example x minus 1 cubed, this time my root is going to be 1. The multiplicity is still odd, but it's no longer 1. If the multiplicity is 3, 5, 7, 9, and so forth, then the graph is going to pass through the x-intercept as a squiggle. And in this case, you'll notice that it kind of looks like a cubic function. That's going to be true for any odd multiplicity that is not 1. And then finally, for a factor of x squared, in this case, the 0 or the root is going to be 0. This time we have an even multiplicity, so for any even, whether it's 2, 4, 6, 8, and so forth, they call this one a bounce or a touch, so it's going to pass through the x-intercept as if it was a parabola type shape. Now, each of these graphs could be going downwards direction instead, so it doesn't have to increase. So in the case of this, if the multiplicity is 1, it could also decrease and pass through as a straight line. For this one, it could be the opposite way facing for the squiggle. And for the parabola, it could be facing downwards. Now, the degree of a function, when you are in factored form, is going to be the sum of its multiplicities. So if I go back to this first example, this is going to be the intercept or factored form that we talked about. So if this were to be multiplied all the way out to become standard form, you could just simply add all of these multiplicities. 2 plus 5 plus 1 is 8, and that'll give you the degree of the polynomial. So even though you don't know what this polynomial would be multiplied all the way out, you can figure out that it's going to be an x squared for the first factor times an x to the fifth for the second factor times x. X squared times x to the fifth times x. You would add all of those multiplicities to get a degree of 8. And in this case, the leading coefficient would be 2. And that's going to be important for other things that we do when we are graphing in intercept form. That is all for this page.